Okay, so welcome to class again. I still have not been able to update the website, so I just wanted to give you a preview of what it will look like once I get it kind of formatted into more of the format I want. So it will have, I typically work by the modules, so you'll go into a module. In the module, there'll be this one module that says handouts and lectures. This will be all the handouts and all the lecture material throughout the semester, so it'll be in a table format kind of like this. So it'll have the unit above it, and then it will have the lecture without the annotations on them, and then it will have a column after the lecture that will be posted, and then the video associated with that lecture. So you can go back and watch these at any time. So this will be how this will be formatted. And then I emailed through the Canvas announcement for the notes for again today, because I haven't been able to update this yet. So if you do want to download those notes, they were on the announcement that I sent yesterday. So going forward, though, for next week, I will have this table, and so you'll be able to have the notes there to access before. So if you don't have a computer or a laptop, want to print them out beforehand and bring them with you to annotate on them, they'll be available by Monday. Okay. Any questions about how you'll be able to access the note material and then the lecture material after the fact? Okay, so I will upload the lectures from this week. Also will be on here, so if you want to go back and watch anything from Monday, Wednesday, or today.
You said that was all in your modules?
Yes. So these will all be under the modules section once I format them correctly. And then the other, so this will be kind of how it will look. You'll have lectures for the semester, you'll have the handouts and lectures, and then you'll have different units, and I haven't decided yet. Maybe I can poll you guys. So I have two options. One would be to do all the material of one unit all together, or I could do it, let's see if I can, where it's by week. So another course I have by week, let's see. So this would be the format, optional format. So I could do it either by week. So you would have each week or each lecture, the material, or I could do it by week material, or I could do it by a unit material. So please vote. Let me get this up and grab a QR code. Okay. So on this, put your preference, whether you would like the modules to be formatted by lecture or by week or by unit material. And then I will format them, whatever your class feels is going to be the most. Yes. Oh, yes. Oh, thank you. Yeah, you do need that to start. Ooh. So again, vote by week, by lecture, or by unit. Okay, this is I think we have a consensus. I don't know if I need to wait any longer. Okay, so by week, so it will be week one, and then on week one, we'll have a Monday, Wednesday, Friday of that material that we'll be covering that week. Okay. All right, that was an easy consensus. All right. Any questions about kind of what it will look like? So for now, ignore, like right now it's done by like lecture 1 dash something or lecture 2 dash something, and you have all these to-do things, like there's probably been a million this week. So I don't like all those millions of them, so you'll probably just have the one, weekly one, that will be like, remember to look at next week's material, and then it will probably have the Thursday nights will be, so there'll be 2 announcements, like you'll get those, like you have 2 things due on Thursday, and then you'll have 1 on Fridays. So you should only be getting the 4 notifications, so every week there'll be, actually I'm probably not even gonna do one for the weekly material. So you'll get the 3 notifications, so every week there should just be 3 instead of 10 or 20. So I don't like the way that it's set up right now. So I will change that, so all the material should kind of be there. If you have questions, once I do post it and you're like, where can I find this material or that, please let me know. There's also, I will also have, I think I have it on this one. Nope, I don't have them here. I'll also have a section, a unit on the modules, and it will have Unit 1 practice problems, Unit 2 practice problems, Unit 3 practice problems, and Unit 4 practice problems. So those will be extra credit, and that'll be great to be able to get practice in. So those will also be available as a module in there for you guys. I must not have done it for this particular section. All right, any other material that you guys would like to request to have on there? Okay. Also underneath the module, there'll be, so for the week, it will have some topics, it will have some section numbers, and it may have like, okay, here's some links to some, like, do these particular exercises in the book, do this kind of problem in the book. So it will have some outline too on what you could read. It will have, it doesn't have it, but get the next one. It will have material content too. Okay, no. Where's the material content? Okay, I need to go back and look at this. Must have formatted the wrong one. So it will have like these learning material on there. So underneath like the learning material, it will look like this, of Ohm's law, power, series parallel. And then under each one, we'll kind of have those exercises, examples to go through, and then some extra video support. So there should be lots of content on there. So look for all that material once I make announcement that it is there. Okay. Any questions? All right, so today we're going to move into Ohm's law, power, series, and parallel. So last time we talked about units, current, voltage, ordinary node, extraordinary node, and we did KCL and KVL, correct? Or just KCL? I can't remember where I got last time. Just KCL. Okay. So I am going to back up slightly then. Okay, so we're going to start at the end of the last one. So we talked about voltage and then Kirchhoff's voltage law. So this is where we ended last time. So Kirchhoff's voltage law is going to be the sum of voltages around a loop. So with this, I suggest to literally put your pencil down on a location on this circuit and draw a pathway around. As you draw a pathway around, as you draw a pathway around, you're going to circle your sign as you go around a loop. So if I physically put my pencil here at this location and I move it around here, I'm going to circle this as I go. Until I get back to where I started. And so literally put your pencil down and mark it like this till you can visually do it as you go. Then you're going to write the circled signs. That's going to be how you know what polarity to write for the signs as you go around. So this would be a plus VDC, a minus V1, minus V2. And then that all equals 0. So the most common error that I see at this stage is that students get the polarity wrong. So you won't circle it, and then as you go through, you write it down incorrectly. If you circle it, you can go back and check. And so this is how you double check that you have the right polarities. So a plus VDC minus V1 minus V2, I'm checked it, yes, that is correct. So I don't have an error with my polarity in this loop. The other error that I see very commonly is when you have a little bit more complicated circuit, you don't go back to the same starting point. So you'll overlap. So once I get to here, I can't go anywhere else because I'm back to the same point. So that's the other thing that I see. So if you do these little dots around, you're like, yes, that is a loop. And I haven't made 2 loops together. Okay, does that make sense? Okay. So it doesn't matter which direction you go. I always tend to go kind of clockwise, but you can go whatever direction that you feel is comfortable. One thing that you notice here is that you do need to have the polarities already labeled. So if a polarity is not labeled, then you need to put it in. What does that negative sign mean if you're thinking about current? Correct. So the negative is the arrow side of that current. So if I was to label current in here, it would be going in this direction, and the plus to minus matches the direction that I've labeled with my polarity of my voltage. So remember with the conventional current, you have a plus and a minus. Label that I. And so the voltage, if it's not labeled and you know the direction of the current, you're going to make the same assumption of the same direction of the polarity. So if this was like I1, you would label that as V1. So what confuses a lot of students is visually like, oh, well, this is going before it. But you have to visually like interpret that that means that it's continuing in the same direction. And so right above it, it would be the plus to minus. Okay, so that takes a minute visually, I know, to kind of get comfortable seeing that. Does that make sense on how to label those? So label them the same as the current and the voltage across the resistors. If neither is labeled, you get to pick which direction you want. Most of the time you're going to assume that, again, out of the positive side of the battery is going to be coming the current. But it's not wrong to assume a different way, solve the circuit, and you're going to find that you're actually going to get a negative current. All that negative means, instead of what you're used to on a numeric scale, is that the negative in a current means it's going the opposite direction. It doesn't mean that it's negative in value. It just means an opposite direction. So that's another concept that takes a minute for students, I know, to think about, is like, oh, well, a negative for me in current now just means it's flowing in the opposite way. Negative in the voltage means that my battery is just flipped. And the way I'm measuring it is flipped from where I've put the probes on there. So value stays the same in magnitude, no matter what now. It's going to be an orientation of the polarity is what the negative means for us as electrical and computer engineers. Okay? All right, questions? You guys ready to delve in and try one? I don't know where one of these days. Okay, find another one. All right, so we're going to work on this problem. So again, introduce yourself to your neighbor if you're sitting by somebody different this time. So write the voltage equation loops and then try to solve for these values.
Like how many miles?
3.2. Okay. 3.2 volts and 2.3 and then 0.5. Okay. That will probably be helpful. 'See if this is the same question. Yeah, it is V6. Oh my. I'm sorry, it is one of these days that errors. Goodness. Okay, that is V6, not V4. Now find V4. Thank you.
Yeah, and so the equation here is ABC equals V1 plus 2. And then maybe since the batteries over here, just start running those and then go
All right, another 15 seconds if you want to put in. Okay, we had some differing numbers up here, which was interesting. So let's see what it will be. So identifying the pathways that you can have. So you have to identify the loops. And a loop is going to be a closed, you go from one and you go back to the same point. So that's going to be the loop. So you have several loops here. One loop would be this one. Another loop could be this one. Another one could be here. Any others? The whole thing? Okay. Oh, wrong thing. Purple. Okay, so all the way around. Any others? I think that covered all of them. Or is it?
Could you do
Oh, yeah, and the
bottom
bottom
square?
one too. Yep. And then the square on the bottom.
But
So-
you couldn't do left and top?
No, because if you do the left, well, you could do
Like the left and top or the right and the top?
you could do this pathway where it comes around and goes
Yeah.
through there. So that would also be a loop. This would also be a loop if you went up through here and around. But it would not be a loop if I went through here, around, and then around the outside. So that would not be a loop. Do you guys see how now with this one you have two different loops that are connecting? So this is where I see some errors sometimes. The students will do this and then they'll be like, they'll go down, but then like be like, oh, well, I can go here. So if you highlight it like this, it's easy to see. But if you don't highlight where your loops are, it's hard to see. So again, highlighting or color pencils, color pens, markers, definitely useful. Okay, so I am going to, so I know, the information I know is this one, V5, V6, and V3. So with knowing these, I'm going to want to try to take loops that have those elements in them because they're the most known information. So if I take a loop here, I notice that I only have V4 as an unknown there. So that could give me an equation with V4 in it. So if I'm going to put my pencil or pen here, and I go up here, I'm going to circle this one, and then circle this one. So it would be plus V4 minus V5 minus V6 equals 0. And then I can solve this for V4 will equal V5 plus V6, and that is 0.5 plus 3.2 for 3.7 volts. So that would be V4. If I, this one. If I do a loop, so now I know V4. So I notice on this, if I have V4 now, then if I do a small loop on that side, I only have one unknown there. So if I do this loop now, I'll have one unknown there. So if I start here and I go up, I have a plus, a minus, and a minus, and then I'm back to my beginning. So this would be a plus Vs minus V3 minus V4 equals 0. And I can solve that for Vs. So that will be V3 plus V4. And 2.3 plus 3.7 for 6 volts. So that one would be 6 volts. looking a little messy, so I'm gonna remove some of these. Okay, so nice thing about the Apple Pencil. I can erase all those. Okay, so last one that I want to get is V2. So I know this one, I know V3 now, or V3 and V5 and V6, V4 and VS, so V2 is the only one I don't know. So I could take a loop around the whole outside, I could take the loop just on the top, whichever preference you have. So I'm gonna just pick this loop and I'm gonna just start here. Again, arbitrary where you start. And I just go around and circling those second signs as I come to them. So this one is gonna be a plus V3 minus V2 plus V5. Or I can do the minus V2 to start, plus V5 plus V3 equals 0, and solving that for V2, I have V5 plus V3, and V5 was 0.5, and V3 is 2.3 for 2.8. Okay, questions? Questions? Yes.
I have a question, when you're doing like the first voltage, how do you tell if it's like positive or negative first?
Wait, which one?
Just like for like volt 2, for example, you started with negative volt 2, and added the other 2 volts, but the previous ones it was positive volt 3 and volt 5.
So, like, why did I do negative V2?
Yeah.
Okay, so as I go around, I typically always take that second sign that I go through as I go through my loop. So you're gonna stick with either always the second one as you exit the element and just circle all of those, or you could always do the first one you come to. You just have to be consistent. So if you always do the polarity as you exit the element or as you enter the element, just stick with them. I'm always gonna do most likely the exiting. So as I exit the top one, it's a negative. And then as I exit, because my pathway went around clockwise. So as I exit V5, it's a plus. And then as I exit V3, it's the plus. So I stuck with always as I exited the element and circled all those. Does that answer your question? That was what you were asking. Okay. Other questions? Yes.
Do you always start at the bottom left and go up, or that is also just
Arbitrary, but yes, I typically do. I like that left corner because I read left to right.
okay? Yeah.
Again, but it's arbitrary where you start. I could start it up here. I could go counterclockwise too.
Gotcha. Okay.
It's just wherever you start, mark it, and then make sure you get back to that. If you have a tablet, it's nice because you can highlight it like I have and be like, here's my loop, and I've highlighted it. You can also copy and paste the circuit so you can have multiple ones of them if you have a tablet. If not, using markers or pencils, whatever you're comfortable with on paper. Some people like to work on paper. So just kind of get used to what works for you. All right, any other questions? Okay, so now this concludes the KCL. So we are going to, so now we have covered all this. So units, current, voltage, ordinary, extraordinary, KCL, KVL, branches and loops. Did I talk about branches in here? Okay. And then we're going to move into Ohm's law, calculating power, and calculating equivalent resistances. So Ohm's law, so this is just kind of that review. Here would be like your loop. So this would be a loop. A branch, remember, is a connection between two extraordinary nodes. connection between two extraordinary nodes. So that's the branch is between two extraordinary nodes. How many currents can you have in a branch? Thank you. One. Yes, just one current only. So remember, only one current in a branch. So one current in a branch. You can have multiple voltages. Multiple voltages, but only one current.
Aren't all currents going positive and negative both ways though? Like, could you say that's two currents?
So the electrons, remember it's an electron flow, so you either use the electron flow direction or you use conventional current. So you only use one.
Right.
And so we're always going to use that conventional current.
Which is positive to negative?
So yes, it goes positive to negative. The arrow is the negative side. So we're always going to use that. And then in your consciousness, I guess, you're going to realize like, oh, the electrons are actually flowing the other way. But we will use always that conventional current. And so yes, the electrons are flowing the other way that the current that we're labeling is going. If you have, like in a circuit though, if you've labeled two different currents, so say I label this I1 and I label this one I2, they have to equal each other. The way they're going to equal each other is that I1 will have to equal a negative I2 or vice versa. So it would have to be that I1 equals negative I2 or negative I1 equals I2. So you can only have one actual current in there. Does that make sense? Okay, other questions? Okay. So this is just a summary. This is from your book, so you can also go back to that and look through these and do some exercises with those. I'm going to skip that one. Okay. Okay, in lab, you're going to look through resistors. Not look through them. You are going to use resistors in your labs. Again, labs start next week. So if you've already taken 1900, then you are familiar with this. If not, then you will see this also in 1900. So just a summary is that, and there used to be apps that you could actually hold your camera over and it would tell you what the resistor is. So if those are still available, you might want to use those than having to read these. But I don't know if those are still available. They used to be and they were nice. But first band tells you the digits. So for example, this one is a brown, which is going to be 1. So this would be 1. The next one would be black. So 0. And then in this one, the third band is going to be your multiplier. So in this case, it would be orange, which is 1,000, the 1K. So this would be a 10 times 10 times, so 10,000, 10K. That's easier to say. And then the last one is going to be your tolerance. So in this case, the tolerance is yellow or gold, which is 5%. So what range does this actually have? What is 5% of 10K? Anyone? 500, thank you. So what that means is that if you have a tolerance of 5%, this is going to range 500 less, so this would be 9.5K to 500 above, so 10.5K. So a really big range of resistor values that you're actually you might measure from just picking up one of these resistors. So may pick it up, may measure 9.8K, pick it up, another one up, and be like, oh, this one's 10.3K. So as you build your circuits, make sure you note what tolerance it is, because you might vary a lot. And then if you're expecting a certain current and you measure it and you're like, well, this is supposed to be 1 amp and it's like 9 or 0.9 amps, it's because your tolerance is so high that you might have a varied resistor there. So note that as you create designs and as you build them and test them, this is going to become important to understand those tolerances. So you can get better tolerances. So the next one down has a 1% tolerance, and the next one down has, oh no, it doesn't, but it will go down all the way down to 0.1% tolerance. What do you think is going to be the trade-off between buying a 0.1 tolerance versus a 10% tolerance?
Cost, price.
Cost. It all comes down to cost. And so that's your trade-off. So as you are doing designs, typically you're going to do the low cost one as you're testing it and just trying to see, does this even work? So you're going to do the ones that are a couple cents versus the ones that are a couple bucks for just a resistor. So note those differences. All right, any questions about the resistors? Yes.
Do they have like a certain direction that like matters? Like if you put it in, like can you flip it
Nope.
into the circuit?
When we come to an element, there'll be a capacitor, and some of the capacitors will actually have markings on them that's a plus and a minus.
Okay.
But for resistors, they're bidirectional. So it does not matter which direction you put them in. That's a good question, thank you. So as you do put these in a breadboard, it doesn't matter which one goes first. They are the same whether they're one way or you orient them the other way. All right, any other questions? Okay. All right, so we are going to move into what's called Ohm's law. So in Ohm's law, it is a equation that you're just going to memorize. So you can memorize it by units if you've liked in physics that you look at units and then you know what the result of that is. So volts is in units, and this is amps times ohms. If not, just memorize the equation itself. So voltage is equal to I times R. From this, you can manipulate it for whatever value you have. So if you have a resistor value and a current value, you can find the voltage across an element. If you have the voltage and a current, then you can find the resistance. So you can write them in whatever known value you have. So if you have the voltage and current, you can find resistance. If you have the voltage and resistance, you can find current. So whichever one you need to know too in order to be able to solve for the unknown. So you can manipulate this equation in different forms. So when I have, actually I'm going to draw it down, a resistor, and I have labeled my direction of my current going in this direction. I label my voltage the same polarities, so they're the same. You can see on the top of each one is a plus, and on the bottom there's a negative. So when I have this orientation, my power is going to be I times V. And the units are going to be watts and amps and volts. So this one again is going to be memorized. So what if I have my voltage and current are now opposite? So say I find the voltage to be a negative voltage when I solve the circuit. You're going to get negative power. And what that negative for power means is I've either am delivering power or I'm consuming power. So the negative for power is consuming, and a positive means either I'm generating or producing. So one theme you're seeing here is that negatives mean a little bit different things in electrical and computer engineering now. So instead of being a numeric value on a scale, they're giving different information to you. So in this case, the negative for power is I'm producing, I'm generating, or a negative means that I'm consuming and absorbing. So that would be the other word you're going to see a lot, is absorbing. All right, questions about power or Ohm's law? All right, what if I have this situation? So say I have a 1K resistor, and I have found the current to be 1 amp, and my voltage is actually going and labeled this way, Vx. What will Vx be here? Okay, so 1K times 1 amp, and then is it positive or negative?
Negative?
It's going to be negative, and why? Yes, it is.
It's gonna be negative because the current and the voltage are different polarity.
Correct. So you notice this. These are different. So my equation, instead of being a positive here, becomes a negative because they're opposite. So that's when you get a negative. So if opposite, Ohm's law is that V equals a negative I times R. Does that make sense? Yes.
So the voltage is a separate polarity than the current?
Yes.
I don't really get that.
So thinking of that, voltage is like a battery, right? So if I had a battery here, draw a battery. Maybe I can draw a battery. Okay, so say I have a battery here. I have all those negative charges and all the positive charges. And I hook this up to a resistor. So on this one, let me do several. This is not, maybe this wasn't a good example. Okay, R1, R2. And across this, so the current is going to flow in this direction. Well, let me put 2 batteries. That will make a little bit better sense, I think. Okay, I have a resistor, and then I've put another battery here. You do opposite. Okay, so say I've done something like this. I've hooked up 2 batteries, and I've hooked up 2 resistors. So the schematic of this is that this goes plus to minus this way, but this one goes plus to minus this way. I'm going to call those just V1 and V2, R1 and R2. So depends on what values these voltages are, these batteries. So all of the voltages have to equal each. Sorry. Okay, we call this X, and this is Y. So all of these voltages have to equal each other, or sum up to be 0. But if you have a very high value, say V2 is, well, let me write this out. So starting here, going through, I have a plus, I have a minus, and then I have a minus. So plus V1, minus Vx, minus V2, minus Vy. But what if, like, I know that just because I've labeled these, but what if I don't know what this was? And say, I just happened to say that I wanted that to be an opposite polarity. So say this went plus to minus instead. That would change that to a plus. And say my current is going in these directions. What I'm going to find is that Vy will be a negative value. So again, the negative just means like the labeling is going the other way. I don't change it, I just say that I notice that it's different. And so that the current and the voltage here are opposite polarities though. And so with this, if I was to find I1 first, so if I1 was known, then I would say that Vy is a negative I1 times R2. Does that make sense?
Yeah.
Okay,
So current and voltage, they're not always opposite though?
correct. Yeah, so they're gonna actually be opposites for resistors. But it'll make more, let's just solve some more problems and then you'll start to see more of it. But that makes sense, right? That they can be opposite or they can be the same. Okay. All right. Okay, so go ahead and work on this one and find. We are running out of time, so I'm going to skip you guys working on it. We're just going to do it really quick. Anybody want to voice if they found it already? Yes.
0.25 amps and 6.25 watts.
Okay, so how did you find that?
25 divided by 100 for I is 0.25, and then I did V squared over R just because it was easier for me. So 625 divided by 100.
Okay, so you could rewrite V in a different form, and like you said, so or I in a different form, V over R. So this could be V over R, or you could write V as I times R and substitute those in. Either way, 0.25 times the voltage of 25 is 6.25 watts. So will a resistor that has a power rating of a quarter watt work here? No, this is way too high. So you would need probably so they usually go up by 10. So 1 watt, 10 watts, so you need a 10 watt resistor. What do you think the cost of a 10 watt resistor would be? It would be expensive. Well, yeah, $1 or $5 or $10 depending on what it is. So this will not work for a power rating of a quarter watt. So note that those resistors also have wattage to them. All right, we'll talk about series and parallel connections next time. Have a good weekend. So next Thursday will be your first homework. I'll get it posted over the weekend if you want to start working on it. Correct. Yep.
Just make sure that you got the email, because I don't want to worry about
Yeah. Let me.